So here again, ladies and gentlemen, I have f of x equals 3x cubed plus 2x squared minus 19x plus 6. And they give us our factors, right? And that's awesome because they know we factors. That means we know that those factors evenly divide into our polynomial, right? Yes, that's awesome. Those are two factors. And we know once we have our factors, we can create our what? Zeros. Exactly. Once we have our factors, we create our zeros because remember, our factors do what to get our polynomial? What do we got to do? What do we do with our factors to get our polynomial? Multiply, right? They're the product. However, does x plus 3 times x minus 2 give us this polynomial? No, this is to the third power. So guess what? We need to include one more factor. So we need to figure out what this factor is. So if I have the zeros, I set these both equal to 0. So I can say x plus 3 equals 0, x minus 2 equals 0. Always set your factors equal to 0 to find the zeros. So you say x equals negative 3 or x equals positive 2. Now, we already know that they're zeros, but I need to find, what the question is asking, is find all the remaining zeros, and I think it even says write it as a product of its factors. Yeah, write it as a product of the factors, and then find all the zeros. So, one thing to do to find all the zeros, I know I have this and times this. Now remember the division algorithm says, if I have a factor, my factor times the quotient gives me my polynomial, right? F of x times q of x, d of x times q of x equals f of x. My divisor times the quotient equals my function. So, you know what? I don't know, let's just do synthetic division. Why not? It sounds fun. That's what the whole section is about, right? So let's do synthetic division for this problem. 3, 2, negative 19, 6. Make sure that your function is in descending order and you take the coefficient of each term. Then, first thing I'll do is I'll drop down the 3, multiply across. 3 times negative 3 is negative 9. 2 plus negative 9 is a negative 7. Negative 7 times negative 3 is a positive 21. Plus 2, 2 times negative 3 is a negative 6. Boom, there we go. Right? You guys agree with that? Okay. Now let's go back and talk about our, alright, so first of all we know that this is our remainder. Here's our constant, linear, and quadratic. So if I was going to say my quotient, my q of x, I would say that q of x is 3x squared minus 7x plus 2. Yes? And q of x times what gives me my function? D of x. And what is my d of x that I used? Huh? X plus 3. Good. Because yes, it was x plus 3. So therefore, I could say that x plus 3 times 3x squared minus 7x plus 2 equals f of x. But now remember, we're not trying to determine f of x though, right? We already know f of x. They're trying to find what are all the zeros. So therefore, instead of writing f of x, let's write this as 0. So now I can apply zero product property, right? I have a product equal to 0. So you could say x plus 3 equals 0, and 3x squared minus 7x plus 2 equals 0. Now here, it's easy to solve for 0. Here, we have to factor. Seriously, Ms. McLogan, we have to factor again. It's a little bit easier on this problem because they already gave us a factor, right? You see this? So guess what? When I do my factoring problem, if I already know that x minus 2 is a factor, what does it has to be in here for me to get my final answer? 3 times 3x minus 1. And now I can zero product property to these. So therefore, x equals 2 and x equals 1/3. So therefore, if I wanted to say what are the zeros, that's the zeros. But what if I said, write it as a product of its factors? Well, I know it's like so much stuff, right? What are all the factors? You already know 2 of them, right? This times this, and we said times one more factor equals that. What was our extra factor we just learned? 3. 3x minus 1. So you could say that f of x equals x minus 2 times x plus 3 times 3x minus 1. So that would be if I asked you, hey, write it as a product of the factors. Then you could write it as a product of the factors. Okay. There you go.